further ado, Enrico, you can take it away.
Okay, hello everyone. My name is Enrico Livelli. I'm a senior software engineer at magnews.com at emailsuccess.com. I'm part of the Apache BookKeeper PMC and the Apache BookKeeper PMC. I'm going to talk about RDB. It's a database, a distributed database that can be embedded into the JVM, and it is built upon Apache BookKeeper. This is the agenda. We will see why RDB was born. We will discuss about the challenges of having an embedded database versus a replicated one. We will dig into RDB data model. We will see how it works, especially the write path. And we will see finally how to use Apache BookKeeper as a write log for a distributed database. So why RDB? RDB is a distributed database system designed from the ground up to run inside the same process of the client application. The project started inside emailsuccess.com. It's a mail transfer agent like SendMail, Postfix, but it has been designed to deliver millions of emails per hour. Email Success is a Java application, and it initially used MySQL to store message state. But in 2016, we started the development of Email Success Cluster, and we needed a better solution for storing message state. We had two new requisites. We wanted an embedded database, a database that can run inside the same Java process, like SQLite. But we wanted a replicated database. This database should scale out and offer high availability automatically. Yes, solutions were already present on the market, but nothing could meet both of the two requirements. Some RDB users in production currently, as far as I know, RDB is used in production as primary SQL database for emailsuccess.com in standard alone version, and it is able to manage hundreds of gigabytes of data with a single machine as a replicated database for emailsuccess.com cluster, as metadata service on Blobit. Blobit is a binary large object storage still built over Apache BookKeeper. If you love Apache BookKeeper, you can check it out. As configuration and certificate store for a Carapace proxy HTTP server. This is a distributed HTTP server. As a SQL database for Apache Pulsar Manager. In RDB collection framework flavor, we will see later, we are using it at magnews.com, and we are using as MySQL replacement in a few other non-open source internal products at dna.com. That's my company. So why another embedded database for the JVM? This is answering the first question. Embedding the database with the application brings these advantages. No additional deployment and management tools for users, because the database is hidden to the user, to the system administrator. You have to only manage the application. The overall architecture of the distributed application is simpler. The application is tested with only one version of the database, and exactly the same version as that you are running in production, because the database is only a library for the application. Email Success supports MySQL, but our customers run multiple versions, different versions of MySQL, MariaDB. So we have to manage and support a very complex matrix of combination of softwares. So working with only one database and the exact version, it's really it really simplifies the development and overall product management. It is easier to test for developers because you can run the database in memory for unit tests, and you are going to use the exact database that you are using for unit tests, because usually for using unit tests you are using simple in-memory databases, but they are not the same as the one you run in production. But embedding a database comes with lots of challenges. First of all, memory management. The database cannot use all of the heap of the client application. So RDB is pretty much good in handling limits on memory usage. You have to come with sensible defaults because the database is a library for the application. So it is not expected that someone tunes it if not needed. You have to enable automatic management routines by default, like compaction, automatic index defragmentation. You have to handle upgrade procedures automatically without manual intervention. Yes, because the developers of the application will focus on the rolling upgrade story of the application, and the database is only a library. So you don't expect, you expect that the database handles all of this stuff automatically. So you have to pay very much attention to the right protocol changes and to these formats. Replication, high availability and scalability. Yes, because you want to replicate, because you want that your application work even in case of temporary or permanent loss of machines. But with a replicated database, you want to keep data closer to the clients. With a replicated and embedded database, you can think that the nodes of the application that works with parts of the data eventually store locally the data that they need. Actually, this is how image cluster works. No shared disks, no network file systems. And you can scale out by just adding machines to the application. Yes, because you're running your application, you have to decide how many nodes for the application and how to scale the database. Shall I scale the database or the application? In the very simple deployment of the application with the RDB embedded, you only have nodes for the application. But other challenges, you have to handle gracefully temporary failures, because if the database runs together with the application and the application is subject to long GC pauses, you have to deal with them. But simply you have to handle application restarts, because when the system administrator restarts the application, it doesn't know that he's restarting the database. And maybe that node of the application is running a part of the database. And so the other clients of the database that are running embedded in the other nodes of the application must deal gracefully with this kind of stuff. It is not so simple to understand the storage topology. You will see in the next slides that the write and log and cold data have separate replication mechanisms. So it is not so easy to understand where data is replicated. You are guaranteed that you have a certain degree of replication, but you have to understand how it works. And you always need some external source of truth. We are using Apache BookKeeper, and yes, it is better to not embed Apache BookKeeper. I'm not going to talk about this. So let's see how RDB cluster works. The data. Data is partitioned into tablespaces. A tablespace is just a group of tables, and you can run transactions and joins that span tables of the same tablespace. So you can perform joins, you can update records on multiple tables, but with the only constraint that the tables stay inside the same table space. And another constraint is that the table space must reside entirely on every machine assigned to it. We will see later. So a table space is made of tables, indexes, primary and secondary indexes, open transactions, a write-ahead log, and checkpoint data. A table for RDB is a simple key-value dictionary that maps an array of bytes to another array of bytes. This is the core of RDB is only a key-value store. But clients, and initially the database started with email success, and email success was working on MySQL. And so clients use JDBC API and the SQL language. You can use Hibernate, OpenJ, PA, whatever, but they are always using JDBC API. So we have a native SQL layer on top of the key value store, and the mapping is simple. The key is the primary key of this column, the primary column of the table, and the value is the encoded, the serialized version of all of the other columns. We are using Apache Site for SQL work, so for the SQL parser and SQL planner. Apache is really efficient, and it is used by many open source products. A table, the assets of the table, you can see table manager in the logs and the code base. It's a data pages. A data page is a bunch of records indexed by a primary key. It's an hash map in memory. We have the primary key index. That's a map that binds a primary key value to the ID of the data page that currently contains the latest value for the record. We have the dirty page buffer. That's a data page that is open for writes. And we have secondary indexes. Secondary indexes simply map values of some configured columns to the primary keys of the record. So when you are updating a record, you just if you move a record to another data page, you do not have to update the secondary indexes. But we also have the RDB collections frameworks that is using directly the key value structure. So let's see how it works internally, RDB, and especially the write path that is the most interesting. Just because initially, HerdDB was for email success, and email success is an MTA, and it is made for speed. And MTA works like this: a message comes into the system, so you have a few records that maps the status and all the other properties of the message. Then the system immediately starts sending it, and then it delivers to the next hop. So you see that it is really probable that records that have been just inserted are updated. So the basic insert update operation works like this. Okay, the client sends the write request, the server validates the operation and writes to the write-ahead log. If the record is a new record or it was in another page, then you can write the new version to the dirty page and update the PK index. But if the record was already on the dirty page buffer, you simply replace it. We will see it in the next slide. You can have multiple versions of the same record. Old versions are discarded during maintenance operations, usually during checkpoints. And if you're working inside a transaction, all of the writes are applied to an internal buffer local to the transaction, and they are not visible to other transactions. And in this case, the write to the dirty page are deferred to the commit operation of the transaction. The second case is that the record is still on a dirty page. So when an update comes, you can simply update the page in place. And this is very common for email success, but for other applications that perform operations like frequent compare and set operations on the same record. It is really efficient. So let's talk about replication and how to use Apache BookKeeper. An RDB cluster is made of RDB nodes, BookKeeper service, the name is Bookie, and BookKeeper server. It is really common to run the Bookie inside the same process of the RDB node, but it is also common to run the RDB node inside the same process of the client application. So basically, the architecture of the application is that you have application nodes and you have some coordination service, and this is the case for Apache BookKeeper. So let's see how it works right. A table space is a replicated state machine. You want that the state of the machine, that is the set of tables and their contents, to be replicated on several nodes. We call these nodes replicas. Among all of the replicas, one node is chosen as leader node. The other nodes are the followers. The client only talks to the leader node for the table space. You can expect, or it is really common in current usages of RDB, to have tens up to hundreds of table spaces with very few nodes, like 3, 4, 5 nodes. So each node is leader for a part of table spaces and follower for the other one. So the client talks only to the leader node. The leader node writes the change to the bookkeeper, depending on the replication factor, but it sends the writes to the bookkeeper. The followers continuously read the tail of the log and apply every operation to the local copy of the table space, exactly in the same order. So they will eventually have the same data for each table in the table space. Nodes, RDB nodes, never talk to each other, thinking about RDB protocol, for read and for write operation in the hot paths. Only for the initial bootstrap of a new replica. If you start a new follower, it is initially empty and it cannot rebuild the old contents of the table space from the bookies, because you are going to truncate the logs sometime. And so the only option is to connect to another node, download a fresh snapshot of all of the data, and then you can start from that point in time in replaying the log. Apache BookKeeper guarantees the overall consistency through the fencing mechanism that we are going to see in the next slide, and the last add confirmed protocol. Apache BookKeeper is the glue and the source of truth. We are using it for service discovery, metadata management, and coordination in general, and Apache BookKeeper relies on Apache BookKeeper for the same mechanism: service discovery, metadata management, and coordination. So we have two levels of replication: the write-ahead log, that's the hot data, and we're using Apache BookKeeper, and the tablespace data structure that is managed by the RDB runtime. We can call it cold data. The BookKeeper client on the leader node writes directly to each bookie in the chosen assembly. So when the client writes, the leader sends the write directly to the to all of the bookies. BookKeeper client is responsible to spread data among bookies and to deal with temporary and permanent failures of bookies, but guaranteeing the overall consistency of the log, because it is really important that followers receive the stream of data in the same exact order of the writes. And it is not so simple. RDB writes to the local disk in these cases during the checkpoint. During a checkpoint, usually the database consolidates the local copy of data at a given point in time, a log position in the write-ahead log. But it has to swap out current dirty pages to temporary files in case of low memory. This can happen really usually if the database has really too few memory, too less memory for working. The write-ahead log truncation happens with a time-based policy. So actually we are retaining data on the bookies for a configurable amount of time that depends on your application. Followers will only eventually store durably locally a copy of the old table space. So when the client writes a new version of the record, the write is replicated to the bookies. So you can have a replication factor for the write-ahead log. If you say, I want 3 copies, you will have 3 copies of this write. But if you have 3 replicas for the table space, those 3 replicas, they will eventually contain and persist locally a copy of the data. Yes. Now let's see how Apache BookKeeper guarantees the consistency of tablespace data by means of the fencing mechanism. Just as an instance, what happens when a follower node N2 is promoted to be leader instead of N1, but during a partial network partition? Corner cases are the most interesting in distributed systems. So let's start with N1, that is the current leader of the table space. The client is sending all of the requests to N1, both reads and writes. But N1 has been partitioned from the cluster. Some network paths are not available anymore temporarily. The client is still connected to it and is able to send reads and writes to the leader node. N1 is still able to talk to bookies, so he is able to make progress. The leader node to make progress has to write to the bookies and receive a successful acknowledgement. But N1 is not receiving notification from the zookeeper, just for instance. And someone updates the tablespace metadata on zookeeper, and the leader is now officially N2. This may happen because the system administrator manually decides to switch the leadership, or it can be some kind of automatic mechanism. But it is important that on zookeeper, the truth is that the leader is now N2. Please note that N1 does not receive any notification from zookeeper about the change of role. How it works? N2 starts recovery and opens all of the ledgers with the recovery flag. This is actually a special kind of write for BookKeeper, and the bookies write and persist durably locally the fact that the ledger has been fenced. When a client that is still connected to N1 tries to send a write, N1 writes to the bookies and receives a special response fenced. So it stops working and it returns an error to the client. Something like, hey, I'm no more the leader for this table space. So the client now starts the discovery again, and it eventually connect to N2 and will continue the write operation to M2. Please note that on the hot paths, the reads and the writes, we are not accessing the metadata service, but the overall consistency is still guaranteed. You will not be able to afford to ask to the zookeeper which is the current leader for every write operation, and it won't work anyway. So let's wrap up. RDB is a good option for you if you want an open source SQL database with built-in automatic replication. If you want to embed your SQL database into your Java application, RDB is running in production. It has been running in production for years with big volumes of data, even in standalone version. Embedding a replicated database comes with these benefits. You can run and manage only the application and hide the distributed database complexity to system administrators. You can run and test the application exactly with the same database you are using in production. RDB replication is based on Apache BookKeeper and Apache ZooKeeper. BookKeeper implements replication for the write-ahead log and guarantees the consistency of your data, especially through the fencing mechanism. And ZooKeeper is the glue and the base for coordination, metadata management, and service discovery. So it's question and answer time. I see a few questions. Why embedded was a requirement? Yes, because our customers with email success, they have to run MySQL and maintain it and maintain the email success, the deployment. So it is really costly. Yes, because for the customer and for the system management, but also for us that we have to deal with lots of combination matrix, and then you are installing MySQL and you are running email success, and then you want to upgrade email success, or you want to upgrade MySQL, and you have to be guaranteed that that it is compatible. So running with an embedded database, it really simplifies totally all of this stuff. If we want to upgrade the database, we upgrade the dependency in image success or in Carapace or whatever, and you get the database upgraded. Another question. Do you think BookKeeper is the new HDFS where systems can create distributed databases easier? Oh, I don't think this is the right approach. HDFS is a distributed file system. BookKeeper is really, really low level. As far as I know, BookKeeper initially was designed for being the write-ahead log of the name node of HDFS, but I'm not sure. You can use it as write-ahead log, and RDB is using it. Twitter, Manhattan, and other databases are using Apache BookKeeper. You can use BookKeeper as storage. As I told previously, in my company, we are open sourced Blobit. That is a binary large object storage, and it is using directly BookKeeper, but it is not a file system. If you are using Blobit, you have a higher level API that deals with some kind of files, but not. BookKeeper is the very building block for storage. Another question. Is table data stored in memory? Yes, Mm, the write path works like this. You get a write and you write to the memory. Data is persisted on the write log on BookKeeper or in the local disk if you are running the standalone mode. When the server is low on memory or the server performs a checkpoint, data is flushed to local disk. So it is not really exactly true that data is only in memory. Usually you are going to keep at least the primary key index in memory, but it is not needed. Another question. How is it compared to Apache Ignite, which has something similar using H2? Oh, Apache Ignite is some kind of distributed cache data grid. The approach is really different because we need a SQL database that really is compliant to the SQL transaction model. I don't know much about Apache Ignite as storage, as long-term storage. I only know about Apache Ignite as a cache, so I can't tell you more. Another question, do you have a layer on top of Bookie for read queries, or does RDB directly read from BookKeeper? BookKeeper is write optimized, but not for cold reads. So do you see I read latency while doing random reads across multiple ledgers? Oh, no. Actually, in the form that I have explained to you now, BookKeeper is used only for writes, and you are going to read from BookKeeper in two cases: during recovery, and recovery doesn't happen very often, hopefully, or for tailing reads. BookKeeper and its own internal architecture of the Bookie. It's designed for IO isolation. So writes go directly to the journal. So a write for a RDB goes directly to the journal of the Bookie. Reads for followers comes from the internal mem table, so they are really fast. Catch-up reads that are used only for recovers, they may be slow, but usually they don't happen. Yes, on BookKeeper we have the write-ahead log. The write-ahead log cannot be consumed as data because the contents of the table is the aggregation of the stream of data on the write-ahead log. So I think it won't be possible to read directly from BookKeeper. In the latest version of HerdDB, we started an experimental implementation that is storing all of the tablespace assets on BookKeeper as well. But it is really experimental, and I think it won't be the case for high performance workloads, and when you have to read a lot. If you want to write, it is good because RDB only flushes to the storage layer only in some particular cases. But if you are performing reads and you have to read the data pages, swap in and read from BookKeeper, I think it won't be the case.
Okay, I think that's all the Q&A that we have. If there are any other questions, feel free to send them in now. Otherwise, we'll go ahead and wrap for the day.
Okay. Thank you very much.
Yeah, thank you, Enrico, so much for that amazing session. I think that the attendees got a lot out of it. And before we wrap for the day, I just want to remind everyone that tomorrow our sessions will start off with a keynote from William McLean from TIBCO starting at 8:30 a.m. All the keynote presenters are going to be in track 1, so that's where we'll have all the attendees start. And then we'll kind of disperse into the track 2 and track 3 after the keynotes take place. And if there are no other questions or comments, we'll go ahead and just end the session. We'll see you guys tomorrow and hope you all have a great rest of your day and stay safe. Thank you.